And here we go. So good morning, Happy New Year and all that good stuff. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so this morning we're going to do a little bit of reviewing from chapter 1, so to speak, but first I have a bunch of information I want to relay to you. Let's see, let's start with the Math Center. Okay, so there is a Math Center available this quarter, and basically you get to it on Zoom. The Zoom ID is listed there, and the hours Monday through Friday 10 a.m. to 4 p.m. and then Monday through Thursday 6 to 9 p.m. So that is available. If you have questions, if you need help and I'm not available, you can always consult the Math Center. All right, let's see. Oh, I know what else I want to talk about. Some of you haven't registered for Webassign yet. If you're having difficulty with that, please email me, or you can come back at 1:15 this afternoon for the Zoom meeting then, and I will deal with that there as well. But I'm not going to take time this morning other than to say, if you've already ordered the material from the bookstore and you haven't gotten it yet, you can go online to webassign.com, click on the login. It'll give you options to create a new account. You can create an account without having purchased one yet and use the student access code that I gave you in the syllabus. That will create a temporary account that will get you by until you get the stuff from the bookstore. But that account will expire after a few days. So if you haven't, you need to order it from the bookstore. And when you've got that information, switch your account over to a permanent paid for account that will last the entire quarter. Okay, let's see what else. Oh, I want to talk about Webassign a little bit and about the syllabus. So let me share a different screen. Here is Webassign over on the left side of the screen. This is actually from like some of the last stuff you'll do this quarter. But the reason that I wanted to bring this up is the following. When you've worked out your answer on your scratch paper and you're getting ready to put it into the box, so to speak, okay, you might think, well, gee, how do I put in things with exponents and all of that stuff rather than just plain old numbers? If you click on the box, notice over here, this stuff comes up here, MathPad, and you can go in and use all kinds of things. For instance, let's say that your answer for this problem is -7f, okay? So you'd put in -7f. Now, and then +4/2f cubed. Well, my point is, if you need to use some of this information here, it's available to you, all right? The other thing I want to point out is that Webassign is really picky. For instance, if I use a capital F, oops, hang on. Interesting. It won't even let me put a capital F in there. Well, that's good. But sometimes there'll be situations where there'll be a lowercase letter or a capital letter as part of the problem, and you'll use a different case and it'll mark it wrong. That's because capital and lowercase are different. Sometimes there's formulas that have both a capital and a lowercase letter, and they are different variables. Okay, so I just wanted to point that out. Next thing I want to do is I want to look at the syllabus. So let's take a look at that for a minute. I want to go over some information. If you haven't already, you should print out the syllabus and read the entire thing. One of the things I want to talk about has to do with the assignment, okay? Or the assignments, I should say. Tonight, there is no actual assignment other than if you haven't already created an account in Webassign, please do so, because tomorrow we'll have an assignment in section 2.1 and it's due Wednesday night by 11:59 p.m. And notice it says due no later than. One of the traps that students get into early on is they think, well, it's not due until Wednesday, so I'll start working on it Wednesday afternoon. The problem with that is if you have questions, you won't get them answered in time when it's due, because at 11:59, the assignment disappears. You can't access it anymore. So what you need to do is on the day that it's assigned, you work on the assignment. So tomorrow, we'll be looking at section 2.1. Then if you have questions, you can email me or you can go to the Math Center Zoom ID and get some help and then complete it either Tuesday or perhaps Wednesday morning so that you're all done in time for when it is due or no later than due. So you need to work on it the day it's assigned so that you have it completely finished by the day that it is no longer available. Okay. Also, the chapter tests. If you click on a test and open it, the time starts. So don't open the test before the day of the test unless you plan on taking it early. You can always do assignments or tests early, but again, once you open up the test, the time starts. All right. Any questions from the two of you that are here about the syllabus or anything that I've mentioned so far? Okay, well, I'll assume that that's a no. So I'm going to go back to my whiteboard screen. And let's take a look at some problems. If I think of some other things I wanted to say, I'll mention them as we go. But today we're going to review chapter 1. So, oh, I know, calculators. That's something I wanted to talk about. So the calculator that I recommended is this one. It's the TI 30X Roman numeral 2 and then S for solar or B for battery. If you do not have the funds to purchase a calculator and you want to use an online calculator, what you can do is you can go to the internet and type in scientific calculator. And one will appear that you can use here. So like 8 divided by 2 equals 4, or let's see here. Anyway, and we'll talk more about that as people ask questions, but I just wanted to point out that there is a calculator available online if you don't want to use one that you either own or have purchased. Okay. Also, yes, I know I'll remember information as we go along. I mentioned when I talked with each of you on the phone that if you have questions that you want me to work out on the next day's Zoom meeting, you can email those to me and request them, okay? I ask that you email them to me before 10 a.m. the next morning, because when I first open up everything on my computer in the morning, I check the emails and write down things for what students want. But after about 10 o'clock, I don't look at emails anymore. I get ready for class. So if you send me a request after 10 in the morning, I probably won't get it in time to do it that day. So keep that in mind. All right. Let's take a look at some problems that deal with vocabulary. The question says this: two fractions such as 1/2 and 5/10 that represent the same number are called what kind of fractions? They are called equivalent fractions. So 1/2 is equal to 5/10. In fact, we could take 5/10 and reduce it down to 1/2. half. Or we could take 1/2 and build it up to 5/10. Okay. Let's see here. This says the result of multiplication is called a what? So 2 times 3 equals 6. You're multiplying factors. Factors to get a, so multiplying factors gives you a product. So the result of multiplication is called a product. All right. 8/7 and 7/8. Those numbers are called reciprocals. Okay. So for instance, the number 3, its reciprocal would be 1/3. The number 2/5, its reciprocal would be 5/2. How about this? If we have 9x squared and 7x squared, those are called like terms because they have the same variable raised to exactly the same power. Now, if we had 9x squared and 7x, these are unlike terms. Even though they contain the same variable, they're different powers of the variable, so they are not like terms. Okay. 0 divided by a non-zero number is equal to 0. But a non-zero number divided by 0, we say is undefined. Okay, so dividing by 0 is undefined. It's all fun and games till somebody divides by 0. Okay, let's see here. I noticed that somebody has texted me on my phone. I don't look at text messages during class, so if it's one of you, yes, thank you. That reminds me of something else. So in Zoom meeting, there's a way to send messages. There's like a message board in Zoom. I do not look at that during class. That just adds one more thing to be confused about. So if you have a question, but you don't want to speak up during the meeting, then email me and I'll get back to you after the meeting. But again, messages sent through the Zoom meeting, I don't look at. Okay, how about this? It says give the prime factorization of 180. Prime factors, they are what? Whole numbers larger than 1, whose only divisors are the number itself and 1. If we take a number like 180 and we break it down into its prime factorization, we're going to write it as a product of prime numbers. Now, 180 is even, so 2 is a factor of it, and 2 is a prime number. So 180 is 2 times 90. However, 90 is not a prime number. So continuing on, 90 is even, so that's 2 times 45. So 2 times 2 times 45, but that's still not the prime factorization because the 2's are primes, but 45 is not a prime. Okay, 2 times 2 times 5 times 9. 45 is 5 times 9. 5 is a prime, but 9 is not a prime, so we're not done yet. 9 is 3 times 3. So in my final answer, I'm going to write the numbers in ascending order. So this would be the prime factorization of 180. You could also write it as 2 squared times 3 squared times 5. Okay, again, recall 1 is not a prime number. We use prime factorizations, among other things, when we're reducing fractions. Okay, for instance, this says simplify. And again, as I'm going along here, if you have questions that you want to ask, those of you that are present, please feel free to stop me and ask your questions. This says simplify 42 divided by 105. Well, a couple of different ways we can do this. One is sort of the chip away method, whereas if we can think of a number that goes into both the numerator and the denominator, we can divide the top and the bottom by that number to reduce the fraction down. If we can't see that, another way to do it is to take the prime factorization of each number, the numerator and the denominator. 42 is 2 times 21, which is 2 times 3 times 7. So there's the prime factorization, because 2, 3, and 7 are all primes. 105 is 5 times 21, which is 5 times 3 times 7, or 3 times 5 times 7. So there's the prime factorization of the denominator. Now I see that both the numerator and denominator contain common factors. The 3's could be reduced down to 1 over 1. The 7's could be reduced down to 1 over 1. And my final reduced form is 2/5. So 42 divided by 105 simplifies down to an equivalent fraction, 2/5. Alrighty. Next we have, it says divide 15/16 by 5/8. In order to divide two fractions, we end up multiplying by the reciprocal of the fraction that's doing the dividing, the divisor. So dividing by a fraction is like multiplying by its reciprocal. Then we multiply straight across, which would be 120 divided by 80, and we can reduce that down further. However, we can pre-reduce, so to speak, and that is because we have what, a 15 over a 5, we can reduce that to a 3 over 1. And we have an 8 over 16, we can reduce that to 1 over 2. 3 times 1 is 3, 2 times 1 is 2, so we get 3/2. Now, we could also write that as a mixed number, though that's not always required. In fact, in algebra, we tend to avoid mixed numbers and tend to stick with fractions. I noticed in the chat that somebody has sent me a message. I'm going to look at that. It says, okay, all right, I get the message, but as I say, typically I won't be doing that, but anyway, yes, I got the message, thank you. Okay, let's see here. I'm going to add 7/10 plus 1/14. To add two numbers with different denominators, first of all, we need to find the common denominator of 10 and 14. The way we do that is to do the prime factorization of each denominator. And then the LCD is the product of the highest power of each different prime factor that exists within these different denominators. So we have 2 to the first power, 2 to the first power. So the highest power of 2 there is 2 to the first power. We have a 5 and a 7. 2 times 5 is 10, times 7 is 70. So the LCD, or the least common denominator, is 70. So 7 over 10 becomes something over 70, plus 1 over 14 becomes something over 70. To take 7/10 and change it into something over 70, we're going to multiply the bottom by 7, which gives us 70 in the denominator. So we also have to multiply the numerator by 7, which gives us 49 over 70. So 7/10 becomes 49 over 70. Okay. To get 1/14 to be something over 70, we multiply the 14 by 5 to get 70. So we also multiply the 1 by 5 So 1 over 14 becomes 5/70. Now that we have two fractions with the same denominator, we can add their numerators over the common denominator, 54 over 70. Now, 54 over 70, I can reduce this. They're both even, aren't they? So I could divide the top by 2 and the bottom by 2 and get 27 over 35. Let's see, 27 is 3 times 9, or 3 times 3 times 3. 35 is 5 times 7. So the prime factorizations don't share any common factors. So this got us nowhere new. Our final answer is 27 over 35. Any questions there? All right. This says subtract, okay? 8 2/5 minus 1 2/3. We can change both of these mixed numbers into improper fractions. So we get 42 over 5 minus 5/3. Remember, you take 5 times 8 is 40 plus 2 is 42 over 5. 3 times 1 is 3 plus 2 is 5 over 3. But in order to carry out the subtraction, I need a common denominator, which is going to be 15. So I'm going to multiply the first fraction by 3 over 3, 126 over 15. The second fraction by 5 over 5. 5 times 5 is 25. 125 minus 25 is 101 divided by 15. Okay. Now, since the original problem was mixed numbers, we're going to take 101 divided by 15 and change that to a mixed number. Recall how we do that. We take 101 divided by 15. That goes in 6 times, which is 90. And then we have 11 as a remainder. So that becomes 6 and 11/15. And I can't reduce 11/15. So that's my final answer. Any questions there? All right. The next problem says write 5/6 as a decimal. Well, we can take 5 divided by 6 and we get, let's see, we move the decimal, we keep adding zeros, we get 48, which then a 2, and that goes in 3 times, and that goes in 3, so it's repeating. So we get 0.83 with a repeating bar over just the 3 to show that that 3 continues. Okay, let's see here. Let's talk about inequalities. It says insert the proper symbol, except symbol has an O in it, not an A. It has greater than or less than. Okay, so -2 compared to -3. Well, even though 3 is larger than 2, -3 is not larger than -2. Consider this: if you were $2 in the hole, you'd be better off than if you were $3 in the hole. Or think of it on a number line. -2 is to the right of -3, so it is greater. So -2 is greater than -3. Okay. What about this? The opposite of the absolute value of -9 compared with 8. Recall, absolute value bars are a grouping symbol. So you do what's inside the grouping symbol first, but the absolute value of the number is either positive or 0, as in the case of the absolute value of 0. So the absolute value of negative 9 is 9, but then this symbol on the outside attacks it afterwards. Negative 9 is less than 8. Okay, any questions there? This problem, we have the absolute value of negative 4 compared to the opposite of negative 5. The absolute value of negative 4 is 4. The opposite of the negative is a positive. So we have 4 compared to 5. 4 is less than 5. So the absolute value of negative 4 is less than the opposite of negative 5. And finally, the absolute value of negative 7/8 compared to 0.5. The absolute value of negative 7/8 is 7/8, and 0.5 is 0.5. Now, to compare these, we need them to either be both fractions or both decimals. Well, if I take 1 or 0.5 and I change it into a half, then I'm going to have to change it to have the same denominator as the 7/8. So it's probably easier to compare them as decimals. So let's figure out what 7 divided by 8 is. Let's see, that's going to go in 8 times 64. And then 6, bring down the 0. That's going to be 7 times, which is what, 56. That's going to be a 40 as a 5 there. So 7/8 is 0.875. Comparing that with 0.5, we see that the 8 is larger than 5 in the tenths column. So the absolute value of negative 7/8 is greater than 0.5. Well, let's talk about order of operations. We've got negative 5.6 plus negative 2. Actually, in here, we don't have to worry about order of operations. We're adding two numbers with the same sign. So you add their absolute values and attach the common sign. Okay. How about this one? Negative 6 plus 8 plus negative 4. Addition from left to right, negative 6 plus 8 would be a positive 2. 2 plus negative 4 would be a negative 2. So the final answer would be negative 2. And here we have negative 1/2 plus 7/8. So to add those two numbers, I need a common denominator, which is 8. Since it already has the denominator, I don't have to fix it. But I'm going to take negative 1/2 times 4/4. So I get negative 4/8. Negative 4/8 plus 7/8. Negative 4 plus 7 is positive 3. So my final answer is 3/8. Okay. Again, any questions, let me know. Here we have negative 10 minus negative 4. Subtracting a number is like adding its opposite. So subtracting a negative is like adding a positive. So now we're adding two numbers with different signs. Okay. So what do? We subtract the smaller absolute value from the larger. So let's see, we've got the absolute value of negative 10 is 10. The absolute value of 4 is 4. 10 minus 4 is 6. But then we attach the sign of the number with the largest absolute value. So final answer, negative 6. If you're 10 in the hole and 4 to the good, you're still 6 in the hole. And if you need more review than any of this, feel free to either email me or to come to my office hour and we can go into more depth. But this is just meant to be just to kind of get your brains going again, getting the cobwebs cleaned out. How about this? Negative 12.6 divided by negative 0.9. Well, Negative divided by negative is positive, so we can change it to a positive 12.6 divided by 0.9. In long division, we'd have 12.6 divided by 0.9. But recall what you do. You want to have a whole number outside, so we move the decimal point one place to the right outside, consequently one place to the right inside. And then we move the decimal point straight up into the answer. 9 goes into 12 once. 9 goes into 36 4 times. So the answer is 14. Let's see here. How about this? -2 times -3 times -5. I should put those closer together. Let's do that again. -2 times -3 times -5. Multiplying a series of factors together, if there is an odd number of negative factors, the answer is going to be negative. If there's an even number, the answer is going to be positive. There are 3 negative factors, so the answer is going to be negative. Now I can go back and just take 2 times 3 is 6, times 5 is 30. It's going to be -30. Or I could do it like this. -2 times -3 is +6. +6 times -5 is -30. Either way works. You can predetermine the sign if it's all multiplication or division, or just drag the sign changes along with you as you go. Let's see, here we have -6.1 times 0.4. Negative times positive is going to be negative. Now I'm going to carry out multiplication. 4 times 1 is 4. 4 times 6 is 24. But remember, I take the decimal point and I move it to the left, the number of digits that there are to the right in the two factors. So let's see, there's 1 there and 1 there, so 1, 2. So I'm going to get 2.44, except that it was negative, so -2.44. And of course, I could do this on my calculator. Let's see, -6.1 times 0.4 is -2.44. And if you have any questions about using your calculator, please ask me. I'm happy to deal with those. Okay, how about this? 0 divided by -3. I said earlier that 0 divided by a non-zero number was equal to 0. It doesn't matter whether the denominator is positive or negative, as long as the denominator is a real number and not 0. 0 divided by that real number equals 0. How about this one? We have a fraction raised to a power. So this is like having -3/5 times -3/5 times -3/5. And then we multiply straight across. Well, -3 times -3 times -3 would be -27. Negative times negative times negative. An odd number of negative factors gives you a negative answer. 3 times 3 is 9, times 3 is 27. And then in the denominator, 5 times 5 is 25, times 5 is 125. So -3/5, the quantity cubed, is -27 over 125. How about this? -3, or excuse me, 3 plus -3. Those are what? Opposites, or also known as additive inverses. They cancel each other out, so the answer is 0. How about 0 minus 3? That would just be -3. And let's see, how about this one? -30 plus 50 minus 10 minus -40. Well, let's see, we could rewrite that as -30 plus 50 plus -10 plus 40. Okay. Addition is commutative, so we could rearrange it and put the negative terms together and the positive terms together. Negative 30 plus negative 10 is negative 40. 50 plus 40 is 90. Now we're adding two numbers with different signs. So we subtract the smaller absolute value from the larger and attach the sign of the larger absolute value. So that's a positive 50 or just a 50. Okay. Let's see here. Let's talk about this situation. If I've got negative 12, negative 12 plus 97 plus 3. It says use the given property to complete each statement. The associative property of addition. The associative property of addition, we would change the grouping symbol. So instead of it being here, it would be there. Okay. How about this one? 2 times the quantity x plus 7. The distributive property, we would get 2x plus 14. So associative property, changing the way things are grouped. Distributive property, distributing the outside number through the parentheses. Let's see, negative 2 times m times 5. The commutative property of multiplication. We can commute these two factors, and then we get negative 10m. So commuting, you change the order. How about, let's see, 1/8 times 8. Using the inverse property of multiplication, this is equal to 1. 0 plus 15x. Using the identity property of addition, basically it says that 0 is the additive identity. Adding 0 to a number doesn't change its value. Exponents, it says write each product using exponents. So this would be 9 to the 1, 2, 3, 4, 5, 5th power. 3 times x times z times z times z would be 3x squared z cubed. Okay. Any questions there? All right. How about this? Evaluate the expression. 8 plus 2 times 3 to the 4th power. Now, order of operations, we would do, what is it? It's grouping symbols, then multiplication or division, whichever comes, oh wait, excuse me, my bad. Grouping symbols, and then exponents, and then multiplication or division, whichever comes first from left to right, and then addition and subtraction, whichever comes left to right. So we don't have any grouping symbols here, but we do have exponents. Let's see, 3 to the 4th power. 3 times 3 is 9, times 3 is 27, times 3 is 81. Then we would do multiplication. 81 times 2 is 162. And finally, addition, 170. Okay. Okay, let's see here. How about this? 3 times the quantity 40 minus 2 cubed all over negative 2 times 6 minus 4, the quantity squared. So the fraction bar is a grouping symbol. It separates the numerator from the denominator. So we'll start at the top, and then at the top, we'll start inside the parentheses. And inside the parentheses, we'll start with the exponent. So 2 cubed, 2 times 2 is 4 times 2 is 8. Okay. Then inside the grouping symbol, 40 minus 8 is 32. And finally, 32 times 3 is 96. So the entire numerator simplifies down to 96. In the denominator, we would start inside the grouping symbol. 6 minus 4 is 2. Then we would do, I guess I don't need to put that here. 2 squared would be 4. Negative 2 times 4 is negative 8. Positive divided by negative is negative, and 8 goes into 96. I can't read my own writing. 12 times. So final answer, negative 12. Okay, let's see here. Negative 10 squared minus 5 plus 6. The exponent is on the 10, not on the negative 10. If I have this compared to that, this means 10 times 10 with a negative sign in front of it. This means negative 10 times negative 10, which would be a positive 100. So it makes a difference. Okay, so back to this. This is negative 10 times 10, or negative 100, minus 5 plus 6, negative 100 plus negative 5 plus 6, negative 105 plus 6, negative 99. Okay, let's see here. Well, that's about it for today. So what I want to remind you of, a couple things. I don't use Canvas, so don't look in Canvas. Don't look in Kansas. Don't look in Canvas for any messages or grades or anything from me. Also, don't send me messages through Webassign. Just use my school email, bmail@ybcc.edu, and it's also at the beginning of this video. Anyway, I'm going to go ahead and I'll stop the recording, and after my other class, so about 12:30, I will post these on YouTube, and it should be there this afternoon under the playlist Math 85 Winter 2022. So again, I'll stop the recording.